Hi, I am Dr. Mohamed Haroon Basha, Associate Professor of Physics, Amet University, Chennai. Let us going to discuss something about the principle and the characterization of laser. The expansion of laser, light amplification by stimulated emission of radiation. The light can be amplified and stimulated and emitted in the form of radiation. The first laser was demonstrated in 1960 by Arthur H. Maimon. The principle of laser, there are the various principles of laser. The principle of laser is based on the spontaneous emission. The laser stands for light amplification by stimulated emission of radiation. Light can be emitted and stimulated and radiated. A powerful beam of laser is a device which ever emit powerful monochromatic collimated beam of light. The emitted waves are coherent in nature. The characteristics of laser, that is the directionality. The ordinary light spreads in all directions and the angular spread is 1 millimeter per minute. But it is found that the laser is highly directional and angular speed is 1 millimeter per minute. The laser beam can be focused a very long distance with a few divergence or angular spread. The next characterization of laser, it is the intensity. And ordinary light is spread in all directions. The intensity reaching a target is very less, but in the case of laser, it can reach the target. It is a high directional nature. That is, the intensity of laser is reaching a target of the intense beam. It is a highly intense beam, and for example, 1 milliwatt power of helium neon laser appears to be high brighter than the sunlight. The laser beam is the highly monochromatic. The wavelength is a single wavelength. Compared to the ordinary light is a more wavelength is there, but compared to the ordinary light which contains a single wavelength, it is the monochromatic in nature. The next important characteristics of laser is the coherence in nature compared to the ordinary light which contains the coherence in nature, which is having the same frequency and same phase. The radiation gives out its mutual agreement is not only the phase but also in the direction of emission of and polarization. The next, the difference between the ordinary light and laser beam. The ordinary light spreads in all directions and laser beam angular speed is less compared to the ordinary light. They are not in directional. This is highly directional oriented and it is less intense. That is, the laser beam is highly intensive nature. It is coherent beam, but ordinary light is non-coherent beam. So there are the laser principle is based on, there are three processes. Number one, stimulated absorption, spontaneous emission, stimulated emission. The basis of stimulated absorption means the atoms from the lower energy state which gets transition, which makes the transition to the higher energy state with the influence of external agency. The external agency means in the form of the laser emission is possible with the three processes: stimulated absorption, spontaneous emission, stimulated emission. The stimulated absorption is the atoms from the low energy state which makes the transition to the higher energy state. During this transition, the external influence occur. Due to this external influence, the transition may pass. That is, due to this transition, a lot of photons will be generated. Then spontaneous emission, the atomic transition from the higher energy state to low energy state without the influence of external agency means that is the spontaneous emission. It is the uncontrolled emission. That is the atomic transition from excited state to ground state without any influence. So the stimulated emission process is very important, essential process for the laser emission. The atomic transition from the high energy state to low energy state with the influence of external triggering. The more and during this transition, more and more electrons, more and more photons will be generated. The photon multiplication is there. The more and more photons will be absorbed by the some transmitted atoms. The laser will be emitted in this process. So the excited state to the ground state transition is possible with the laser emission. The difference between the stimulated emission and spontaneous emission means the spontaneous emission, the atomic transition from the higher energy state to low energy state without the influence of external triggering or external agency. But in the case of spontaneous stimulated emission, the atomic transition from the higher energy state to low energy state with the influence of triggering, more and more photons will be generated during this transition, more and more photons will be absorbed, and then laser emission will be possible. And the laser emission, that is denoted by the energy E is equal to E2 minus E1, that is the excited state to the low energy state, that is E is equal to E2 minus E1, that is the laser emission process. So the next the laser emission is very important. Laser action is mainly depends on the population inversion. Population inversion means the atoms, the number of atoms in the low energy state, which is denoted by N1, and the number of atoms in the higher energy state, which is denoted by N2. So during this transition, the more and more atoms should be there in high energy state. That is, the number of atoms in the high energy state should be greater than the number of atoms in the low energy state. So in order to achieve the population inversion, the pumping actions is required. There are 4 types of pumping actions. Number 1, optical pumping. Number 2, direct conversion method. Number 3, electrical discharge method. Number 4, the atom-atom inelastic collisions. The optical pumping method is the active medium, that is any solid state laser or gaseous laser is there. The external influence is there, means the number of atoms to the low energy state to high energy state with the influence of external triggering. That is the krypton xenon tube is used for these actions. So the more number of atoms in the high energy state due to this influence of triggering. So the number of atoms in the low energy state is high here compared to number of atoms in the high energy state. That is, N1 is greater than N2 here, but after optical pumping or pumping method, the number of atoms in the high energy state is compared to the low energy state is high here. That is, N2 is greater than N1. So in order to achieve the population inversion, we require the pumping actions. We achieve the population inversion, that is the laser emission is possible. Condition for population inversion, that is there are 3 types of population inversions conditions. There must be at least 2 energy levels, that is E1 and E2. Okay, then there are the source supply, there is a source supply of source is there, and number 3, the atoms would continuously raised in excited state, that is the number of atoms in the N2 should be greater than N1. The influence of electrical energy, the electron coal pair is there in the junctions which can be emitted as a light emissions. So the electrical energy is converted into light energy, that is the direct conversion method. And electrical discharge method, for using the electrical discharge method, there will be the electrical discharge tube is there. The electrons is accelerated, then first the electrons is accelerated in the electrical discharge tube. This can be first the electrons due to these accelerations, the electrons from the ground state, which is gets the excited state, more and more atoms in the excited state, the population inversion is achieved. So due to this population inversion, the laser emission is possible. The next method for the pumping method is inelastic atom-atom collision. In helium neon laser, the inelastic atom-atom collision is possible. First, the helium atom is in the ground state, which is excited to the excited state, then which makes the collision with the atoms, with the neon atoms. The neon atom which absorbs the energy from the helium atoms, which gets excited. The more and more neon atoms is there in the excited state, the population inversion is achieved. The laser emission is possible with this population inversion. So next important parameter is the optical resonator. Optical resonator is the two convex mirror, one is fully reflected and another one is partially reflected. One is fully silver coated and another one is partially silver coated. Then in between these two silver coated convex mirrors, the active medium is there, that is the active medium is there. So the laser emission is possible with these two convex mirrors. Various applications there in the laser, that is the engineering and technology applications and medical applications and fish finding applications and military applications. A lot of applications is there in the laser. It depends on the laser. So laser is a powerful and monochromatic and collimated beam. Light can be amplified and stimulated, and stimulated radiation occur, that is the laser expansion. Okay sir, just I explain again. The laser emission is based on the three processes: the spontaneous absorption, stimulated emission and the spontaneous emission. The spontaneous absorption is the atoms from the low energy state which makes the transition with the influence of external triggering to the excited state. And this spontaneous emission means the atoms from the excited state which makes the transition without the influence of external triggering, means that is the spontaneous emission. And stimulated emission, which is mainly based on the laser emission. The stimulated emission is the atomic transition from the higher energy state to low energy state with the influence of external triggering. During this transition, more and more photons is generated. The photons will be observed and the more photon multiplication is possible with this laser emission. So right now you know very well about the laser compared to the ordinary light, that is the powerful and monochromatic and collimated nature. So thank you very much.